Hello everybody, hope you're doing well. This is week 8 and we're going into the fuel systems labs on this 2006 Toyota Corolla. So as you can see, here's a basic mock-up of the fuel pump with an accompanying connector port. There's 1, 2, 3, 4, 5, however we're only going to be worrying about 4 and 5 because that's battery positive and negative. So in order to access the fuel tank on this 2006 Toyota Corolla, we have to pop up the back seat cover, pop off this little cover right here, and now we have access to all of our circuits. As you can see from this wiring diagram right here, between pins 4 and 5 is our fuel pump, and then above pin 4, up here, is our fuel pump relay. It is important to mention, however, this vehicle has a returnless mechanical fuel pump system.
Alright, we got our relay, we got it bypassed essentially, and now that shuts off the fuel pump.
So this is our voltage drop test at the fuel pump across this power and ground, and as you can see, we're getting no volts. Well,
Good.
I'm getting 13 volts, so good. Alright, that's good. So as you can see from this diagram on all data, this is the procedure it wants us to do when testing fuel pressure. It wants us to create an open in the actual fuel line, preferably towards the front of the engine. That's probably where it's going to be most ideal to access. And it wants us to create this T-joint so that we can hook up a pressure gauge to it so we can actually monitor fuel pressure. Alright, so according to all data, it wanted us to cut part of the fuel line open to insert a T-joint. However, we already had a T-joint and we wanted to try doing it on our own. However, as Sean will show you in a minute with his videos, it was unable to work, but we did try to measure fuel pressure. So currently we're measuring PID readings with the car running. As you can see, the fuel pump is on, and right there is when we actually turn the car on. Same thing with the injector, although we're not really worried about that right now. I'm now bringing it to 2,000 RPM. Alright, I'm now holding it at about 2,000 RPM. So moving on to injectors, and looking at this map of the wiring diagram, we can see all of our injectors here, and obviously they're located on top of cylinder heads. They're very easy to get to. Now some of them, actually all of them, they have linked directly to the PCM, and we're going to be testing there as well for voltage drop. But we can see the remainder of the wires go throughout the engine, and of course some of them go to the ignition coils, and obviously these are ground side controlled. Taking another look at our injectors on the wiring diagram, this one's in black and white, however we can clearly see which pins these go into in the ECM, number 10, 20, 30, and 40, and obviously these are all black and white wires, they're all the same, so that you know where power is coming in from, but obviously all the wire colors going out of it are different colored. Alright, so as you can see, we are testing waveform on the injector, and our current is stopped right now, but this is our setup. Stop! As you can see, the propane keeps the engine running. If I let it off, get off the throttle, Sean! Get off the throttle! What?
You're right. It keeps you running.
So from the previous video, you can obviously see that we're injecting a propane directly into the engine. However, this was not very easy because it was hard to find an actual intake port. So we just hooked it up to a vacuum line. Now without this vacuum line, the engine would have stopped and died. But with it plugged up and with propane going directly into the engine, and obviously the chemical composition of the propane, it was keeping the engine alive and probably causing it to run rich.